So it's time to start the session. In the first, we have Professor Dr. Sami Mitra, who is the editor in Physical Review Letters. He will talk about the pointers on publishing your paper in a selective science journal. So I will request Professor Basit to introduce him to the audience.
Okay, thank you again, Dr. Sabrina. Dr. Samindra or Dr. Sami Mitra grew up in Kolkata and Delhi and received his PhD at Indiana University, Bloomington in 1994 on theoretical aspects of the quantum Hall effect. After working on chemical physics at the Albert Einstein College of Medicine in New York City, he joined Physical Review Letters. Among his other responsibilities, here he deals with papers on transport properties in semiconductors, 2D materials, and mesoscopic systems. We are really excited to be exposed by your speech. Microphone is over to you, Dr. Sami.
Can you hear me?
Yes, please.
Thank you, Professor Basit. Also thanks to Zahid for making the connection. This is, your program looks extremely interesting, and I might dip in and out in the course of the next day or two. And my short speech here is really more of an introduction. It's hopefully the beginning of more similar sessions and workshops that I can participate in future. I'm always available, especially, and maybe one day I will be in Dhaka to watch the rain, as somebody said, and I'm in New York, just outside New York City right now, and it was raining extremely heavily last night, so it's the same weather in both places. I'm going to share my screen a little bit, but this is very informal, and if somebody wants to ask me a question, please feel free to stop me and ask the question, because this is not a science talk. It's more of a discussion. We don't have much time, so these discussions can continue in the future. So this is more like a tasting for the possible future discussions. So just let me know when I share my screen if it's working at your end. Does it look good?
Yes, it looks perfect.
Full screen, okay?
Yes, it's okay. It's loading, no problem. It will be okay. It's loading.
Right.
Yes, it's perfect now.
So you can see the title is just this, what Dr. Elias mentioned. It's just some pointers. And again, given the brevity here and the necessary because of the time constraints, I'm not going to make any kind of comprehensive presentations, just raise a few points that people submitting to a selective good science journal should keep in mind. There are, of course, many more details that one can talk about, and I think you have speakers later in the week who will go into some nuts and bolts, as they say, of how to write a science paper. Professor Shamshir Ali mentioned a few things about the length and so on. All of that is very important. Just to give you an introduction, this is the URL to the journal Physical Review Letters. I'm not sure what fraction of the attendees have a physics background as opposed to some other sort of science background. So you may or may not be familiar with Physical Review Letters. It's a large yet exclusive physics journal. It's large because it publishes over 2,000 papers a given year. It's exclusive because it's large, not because it publishes many papers in a given field. It's large because it publishes in many different areas of physics. And in each particular area, it is exclusive. It publishes very few papers in any given topic. And then there was some discussion about predatory journals at some point earlier. This is an existential threat in the landscape of science publication. And I feel somewhat hesitant showing the next slide because it's somewhat self-promoting. But the next slide tells you what the opposite of predatory publication is. So this is PRL, which has had a stellar record, as some of you, I'm sure, know, in publishing important, very important physics papers. So much so that in the last 11 consecutive years, physics papers that received the Nobel Prize were cited, published in PRL. So, for example, the most recent 2021 was, and then of course, some of you may be familiar with the papers from 2017, which discussed the discovery or the observation, if you will, of gravitational waves and so on. And going forward, the first pointer I wanted to raise is the outreach tools. By outreach tools, I mean the components through which the physics research that is carried out in the lab or at your desk in front of a computer or with a pen is conveyed to readers outside your immediate circle. And those tools there are not that many of them. So you have, for example, you have at the beginning, you have short talks and posters at conferences. Now, when you're presenting these short talks and posters, you are speaking to a specialized audience that is quite familiar with what you're doing. Some jargon there is probably okay because they speak the same language that you do. Their expertise matches that of yours. Now, as you move along, either further in your career or in time, you write papers that are for journals, good but specialized journals. There you're writing for a slightly broader readership. And then as you move even further along, you're giving invited talks and such at conferences. In that scenario, many people sitting in front of you during that talk may not be from your field. So then you have to be very careful about not using too much jargon. And as a speaker, it is in your interest to reach out to that broad, non-specialized audience. Now, this, of course, goes on. And then when you have papers that you're writing for broad journals, such as physics or one of the nature journals and such, these are papers that you're writing for readership that is often the overlap between what you do and what they do is not much. So there, of course, you have to make more of an effort to reach to a broader audience. And finally, of course, for all of us in any country that you're in, whether it is in the US or Bangladesh or India, ultimately, the funding for basic research, the basic science that you do comes from mostly the government, which by extension means the taxpayer. And so it is in the interest and the responsibility, I would say, of every scientist to broadly educate the broad public on what they're doing. And it's a very tough thing to do because often the public is not particularly well informed about various aspects of science. And in some cases, this is more important than others. So as we have recently seen with the corona pandemic, that the ability of the public to understand the science or the progress behind vaccine research, for example, the ability or lack of ability to understand has led to what we call vaccine resistance or vaccine hesitancy, which has clear direct effect on people. So that's and this in the world of physics, this appears also, for example, in nuclear research and such. Okay, now this is a message to the person writing the paper, as you can see here. So when you're writing a paper, you may think that your work is important. You may think that your work is clear, that the science is clear, but you're not the audience, immediate audience. You're just the writer. The audience are people such as editors, referees, and eventually readers of your paper. And it is in your interest to persuade them that the work that you've done is important, has a suitable message, and so on. So you have to, in some sense, put on the hat of these people. And they are almost always, perhaps except for the referees or some of the referees, going to be less of an expert in the field of research. So it is your job as the writer, as the researcher, to make things easy for editors and readers. And how do you do that? I hope and I urge everyone listening to this talk to get a copy of this book out here. And even in India, I know it's very cheap, freely available. And this book has great lessons for all sorts of writing, including science writing. And these are the three most important words in that book. I think this goes along with what Sami I think Professor Shamsher Ali mentioned a little bit earlier, is that when you can say something in fewer, simpler words, do not use longer, complicated words. That's the first most important lesson. Another point I would raise when you're writing a science article. So as I mentioned earlier, I mean, my talk is necessarily very short. And so perhaps if I end early, we can have a longer Q&A, but anyone wants to interrupt me with a question at this point or at any stage, feel free to do so. I can only see the panel with some speaker icons on the right, but if there's a question is raised, I suppose somebody could chat or something. Okay. So going forward, I mean, you have the typical science article, of course, and the ones in our journal are typically 4 to 6 pages long, different articles of different lengths and so on. But the important thing to kind of think of is that most readers are busy. They do not have the sort of experience that you have as the author of that article, and they are selectively looking at some parts of the article more carefully than other parts. And typically, this means that the parts of article that they're looking at most carefully are the title, the abstract, the introduction, the figures, the conclusion, and also the references. To give you an example, the title, for example, you might think that the title is just, maybe 5 to 10 words, a single sentence, not even a complete sentence. Why is the title so important? Well, a couple of things. So just to give you an example, the title of the year 2022 has a whole different meaning in relation to the title of the year, let's say, even 10 years ago. Because, every time there's an important physics paper or an important science paper, there are people who tweet about the paper. And when they're tweeting the paper, they're not going into the sort of detail that you as the author would like. They're taking, usually just the title of the paper and maybe some other sections of it. And so this title floats out into the world without the context or the PDF behind it. And whatever meaning the title can convey is the first, as we say, the first hook, the first impression that people get of the paper. So therefore, the title is important. Also, for physicists in this audience, as you know, we have the archive, which is the preprint servers, where the preprints of the papers are listed. When you land on the archive front page, you do not see the paper. There is a PDF to link to the paper. You do not click on the PDF. I mean, you don't see the paper unless you click on the PDF. All you see on the first page are the titles of the papers and the names of the authors. So if you're familiar with the authors, then okay, it carries some meaning, but otherwise you're just going by the title. It's the same kind of thing with the abstract. The abstract is in the day of search engines. So you have, for example, Google Scholar or Inspire, for example. And many people search for research that they're looking into by doing what are called abstract searches. But these used to be called abstract searches. Now they're just Google Scholar searches and so on. And so this abstract that you write should have a good collection of the important keywords in your paper. So for example, if you've written a paper on, let's say, photo emission effects in high temperature superconductors. If your abstract somehow does not have the word photo emission, then all of the people who are looking for such effects in certain superconductors will not discover your paper simply through the first order literature search. So it's important to think of the abstract as a paragraph which is well written, concise, and so on, but it also needs to have the relevant keywords that tie your paper to the outside community. Same with figures, as you know, and this happens not just in the world of physics. People often try to go to the figures and the figure captions and try to get a sense of what the paper is about, hoping that they will not have to read the details. So it's important to have good figures. Sorry, let's see what's going on here. Here is a recent publication from 2022. I just wanted to give you an impression of what a good title is. So here is a pretty good title, I would say. So here is the title, you can see. And there is no ambiguity here. There is no big words, not much ambiguity. All you don't know is what the imaging is. what process is the imaging done by, and that is evident in the abstract. You can see right here, they use something that we call nitrogen vacancy center magnetometry. That's a big word. They decided not to put it in the title, but otherwise it's a simple, precise, focused title. No big words right there. Going forward, another thing is I talked about the introductory sections and so on. I've highlighted here for you. Often you'll find when you read a paper, they go into who did what before and a big landscape kind of introduction. But you as the reader are quickly trying to drill in to find out what the authors did, why they did, and such. Sometimes this information can be difficult to find. And to me, if that information is difficult to find, the paper is not particularly well written in the introduction. Here, on the other hand, as I've highlighted here, you can see it's very precise. They tell you exactly what they did. The first sentence tells you exactly what they did. The second sentence then goes into some specifics as to their, again, the magnetometer and what kind of. So people, of course, this information may be, as you go down this paragraph, it gets more and more detailed for the expert, but you get a good sense of what they did just by looking at this. So that's kind of an example of what I would call a well-written paper where certain things are quite clear without much effort for the reader. For the younger members of the audience, I'd like to point out that in our journal, and other journals do this also, we have a free highlighting journal. This is called physics.aps.org. So they highlight certain papers that are deemed to be important, significant, whatever word you want to use. And if you go to this website, then if you click on to the papers that have been highlighted as viewpoints on this website, those papers, those PDFs are available free. So that's a good way to get a sense of well-written papers where you can look at the paper, get a sense of the paper, and if you need extra help, then there is this highlighting viewpoint article that tells you what the research was. I think it's good practice to have examples in front of you as you're moving along. So another way to get comfortable, I'll try to end it in about a couple of minutes, is to exit your comfort zone. So here, the most important advice I would give to, for example, the early career PhD student or even a postdoc, or even later, I would say, is that when you write a paper, you've written the paper, let's say you're satisfied with it. Your advisor, your lab colleagues are happy with it. But don't forget that they have been discussing this paper with you for weeks and months. They're completely familiar with what you did. So my advice would be to take that paper, find a scientist who is roughly in the same sort of field that you are in. So if you're a chemistry person, it could be a physicist. And then ask them to read the paper, at least the introduction and the conclusion, and give you some feedback. If that person is unable to understand or realize what the significance of the paper is, then you'd need to work on it more. I'm going to skip this page. This page is not important. So another point I wanted to make, and this is a true, so in a good selective journal, which is PRL, for example, or, as you know, the Nature family of journals, Nature Physics or Nature. These are, most papers that we receive are good, significant papers, and they're not incorrect. In other words, when these papers are reviewed, the referees are not telling us that there is something wrong with the paper. The referees often do not find any errors in the paper because these papers that are submitted to us are really good, significant papers. So then the decision to not publish them, because we are only publishing about 1 out of 5 papers, has an element of subjectivity associated with it. So I think one of the things is to realize that some journals publish some articles, other journals publish other articles. They have particular criteria, and the criteria are not always whether it is scientifically correct or not. There could be other criteria. One of them could be scope. I mean, you could submit a journal which is more chemistry leaning, and your paper may be something that is more suitable for biochemistry, for example. mean, these are things you have to consider. So my point here is that you need to know the journal to which you're submitting the paper. That's it. Thank you. And I'll unshare my screen and we'll be very happy to take some questions. There may be some in the chat. I'm not sure. All right. Okay. Can't see the paper. Somebody said. Somebody can see the paper. Somebody can.
We have seen it.
All right.
It was clear. Thank you very much, Professor Dr. Sami. You actually, we requested you for 20 minutes because we think you have a very busy schedule. But we didn't.
No, I'm here. I'm okay. I'm not so busy this morning.
Okay. So I think there might be a very nice discussion session here. We got some time. We have huge time to discuss. So I'll request for some questions or any discussion. Anybody can start any discussion, any question with Professor Sami Mitra.
There is a question in the chat.
Yeah, I see that. I have a question. After writing the paper draft, how will I improve it to avoid critical peer review? Is that the question?
Yes.
Yeah. So the first thing I would say is peer review will more often than not, if you're submitting it to a good journal, will be critical. And most good journals will reject more papers than they will publish. So for a journal like PRL, we will publish roughly 1 out of 5 or 1 out of 6 papers. So most very good papers will get turned away after the peer review process. But from the point of view of the questioner, you should not try to overthink this issue. Your aim should be to try to figure out if the paper as you have written it is the best that it can be from your particular resources. And the other is it a good fit for the journal? And to me, this is for an early career person is exactly where you need to have a discussion with your peers and your supervisor and your people who have been in the field for some time. So for example, if you've written a paper in physics and you're debating whether you should submit it to PRL or you should submit it to one of the more specialized journals, either in the physical review family or some other publisher, that's a question that I think that early in the career, you may or may not have a good sense of it. And if you don't, that's a discussion you need to have with your supervisor, or maybe not even your direct supervisor, but with colleagues in the institution who have done this sort of thing before. And I think that is also one of the responsibilities of the more experienced scientists while they're mentoring their junior colleagues to kind of advise them that, okay, this paper you think is significant, appropriate. However, I think it's a better fit for that journal and not this journal. Journals are pretty good about telling you right away if they think it is not going to get published, because but there are some papers which editors don't know if they'll be published. So they send it to referees and it's kind of on the borderline. So it goes through the process for a few months and then some sort of a decision is made. And again, like I said, majority of times those decisions are going to be negative. So the short advice is you must talk to your colleagues before submitting the paper. Don't just write the paper yourself. Don't talk to anyone and then submit it to a journal. Not good.
Thank you, Dr. Sami. Any other question? Anybody can please raise your hand if you have any question. Anybody?
Please.
Okay, so on behalf of students, I can ask one question, Sami. When we arrange this sort of program, one question is very common from the audience, particularly from the young researchers. So what is actually the notable difference between abstract and conclusion? What they should include in the abstract and what they should mention in the conclusion and in the concluding remarks. So what is your suggestion? These two
notable difference between the abstract and the conclusion is what your question?
Yes.
Well, I mean, the important thing is that the abstract is something that you have to almost visualize as floating out without the paper. So to me, the advice would be the abstract should be somewhat meaningful, even if the person has no access to the paper. That's my point. So it's a short, you have to kind of, it's almost like it's in the US, they have this term called elevator pitch. Does this mean anything to people? So elevator pitch means that you're starting a new business. You are, you get into a lift, which they call elevator here, and you get stuck. So your lift is going from the first floor to the 10th floor, and you have 2 minutes in which you have to make your pitch to somebody. That's it. That's the time. So to me, I think the abstract is kind of like that. It's a very concise, 50, 60 words, can't be too long, then people get bored. And that's it. You just tell them something about the paper, give them a vague idea. The conclusion is different. The conclusion is, and to me, sometimes the conclusion and the introduction is similar, and there even could be repetition in there. The conclusion, somebody has presumably looked at the paper, at least glanced through it, and they are thinking, okay, they did this, they did that. I'm not quite sure what's the, as they say, takeaway message. That's the conclusion. Conclusion almost tells the person, now that you've looked at the 4 pages or 10 pages of it, you may be confused, but this is what we really wanted to say. That's the conclusion. And in some cases, the conclusion sometimes will go into possible future work and so on. But that's, to me, a lesser part of the conclusion. The more important is just to tell the reader, okay, this is what we told you in case you did not understand it when you were looking at the 10 pages. That's the difference.
Thank you, Dr. Sami. Is there any question from the audience?
I see some questions. Suppose I use a concept that most people in the field I'm publishing in are unfamiliar with. Is it better to include a brief section explaining it, or should I just cite some paper that explains it? I think both. I think you should absolutely cite some paper that explains it. But obviously, if you have explained, if that paper has it, then you're not discovering it. You're not, coming up with it from, it's not your discovery. So you have to cite the paper for sure, because you do not want to give the impression that you are the first one to come up with it. But then you don't want people to always have to go back and forth to some other paper to even go through your paper. So you should try to explain it to help the reader. But again, omit needless words, keep the explanation short, just to give a pointer. So that's the first question. Second question.
Yes.
These days, people talk about interdisciplinary research. You said most of the very good journals. On what parameters young researchers decide where the journal is considered very good? Do you think impact factor is one of them? The first answer to what a journal is considered very good is, as with pretty much everything else, a journal is good if people who deal with the field, who are practitioners in that field of research, consider it to be good. So that's the reputation of a journal depends, well, firstly, whether it stands the test of time. There is some element of that. So for example, our journal has been around since 1958. It has stood the test of time. But that does not mean that a journal that is only 10 years old cannot be very good, right? So time alone is not a factor, but certainly if you have test of time is important. The question simply is whether that journal is regarded as respectable and good by people in the community, particularly by people in the community who are going to make decisions about your career. So one example I'd give is, suppose you are a postdoc, let's say, who has done some work somewhere, maybe at Manchester, as somebody said, or some other good place, and you're applying for a faculty position at Dhaka University. What would that selection committee consider to be good? I don't know. They could have various, and depends on the field. So if you're applying for a nuclear physics position, what journals would be considered respectable, what the impact factors of the journals should or should not be, that decision-making process may be quite different from if you're applying to a position in polymer physics, for example. So it depends largely on the practitioners and the faculty in the field, and you should talk to them. This is one of the, to me, this is one of the processes of the post-PhD education process, I would say, to get to know which conferences are good conferences, which journals are good journals, which colleagues you should be talking to when you go to these conferences, and so on. All these are, the impact factor, somebody asked, the impact factor is certainly one of the considerations. However, the impact factor is not the only consideration for various reasons. And for example, two of the reasons are the impact factor that is considered to be very good in one field may be considered not so good in some other field. the average impact factor for a chemistry journal, for example, could be 5 times that of the average impact for an equally good math journal. So you have to know the field. The other thing is, of course, the impact factor. There's the journal and there's your paper. So you could be publishing, many of your papers in high impact factor journals, but your individual papers may not get any citations. So then you're just, it's like, if you're playing football, you play for a good team, but you're always on the bench. Then should you benefit from being, I don't know. I mean, when you go up for, in India, they have the IPL auction. They obviously don't just look at the team. They look at your personal playing record, right? So, okay.
Thank you, Dr. Sami. Is there any question? We can accept 1 or 2 questions. Just one student asked, among a large number of experimental findings, how should anyone select what to include in supplementary file?
Well, the supplementary, that's a complicated question. I think in general, the way we feel in our journal, different journals have different points of view, is the supplementary file should only have information that would not be necessary for people to read the paper. To me, the way I think about it is if you're reading the paper as an expert in the field and you are routinely coming across data or experimental details or instrumentation details that you feel that you have to keep emailing the authors, let's say, to say, oh, can I have that information? What was the spectrum there, or what kind of sample did you use here? All these questions, if they keep coming up to you, it will be helpful if the authors are including that information in the supplemental material. That's the way I think about it. But somebody who is not actually working in the field would have no reason to, think about those things. So that would be make it supplemental. Something about please say something about reference list of a paper. I don't understand that question.
I think he's asking what should be the authentic references. So what is the importance of inserting the best references? And
I think referencing is very important. You should always, there are 2 rules about referencing, I would say. One is it should be helpful to the reader. It should help the reader get the background. The second one, I think, is you should always provide references because you should not give the impression in a science publication that you came up with something on your own if you did not. So if there is some, discovery or some reference, some calculation that you're referring to, more often than not, you're not, as an author, you didn't come up with it. Somebody had done it before, then it should be referenced. Okay. Otherwise, you're giving a false impression, is what I would say.
Okay, Dr. Sami. So I have a last question, actually. My question is not only my question, questions from our students and young researchers. This is probably a rude question, actually, for the editors and the reviewers. Recently, we feel that some reviewers have to cite their own papers, which are not completely relevant to that story of that paper. So this is, we think this is scientifically not so good. So as an editor or from publishing point of view, how can you restrict this sort of practices?
Yeah, I mean, you said recently. I don't think this practice is recent. This practice has been there forever. I mean, referees, well, I mean, in some cases, so as an editor, my point of view is, if the reference is relevant, the fact that the referee is asking for it or not is irrelevant. If it's relevant, other experts in the field, they would say, no, this is not that. If the author strongly feels that the referee is asking them to insert a reference which is not relevant, then in our case, different journals differ, I would advise the author to set, when they resubmit, for example, after they revise the paper, to send a note, and authors do this all the time, in which they write to the editor, not to the referee, to the editor, saying why they think that particular references are not appropriate. And then we will take them. And in fact, we routinely publish papers in which certain references are not included, even if referees told us to include them. So that's very common. So,
thank you.
Thank you very much. I don't know, my time is obviously over, but as I mentioned before, I'll be joining in and out for some of these sessions. I don't know if you have any kind of breakout here or not, but I will be in conversation with Professor Basit, maybe for joining some subset of you people, participants at some future forum of something. I'll be very happy. I didn't have this. I really didn't know much about this particular enterprise. Zahid told me more about it, and that's how I found out. So I'm very happy to be here. And it's it looks very interesting, actually. That's why I was telling you that some of these topics look very interesting. So I'll probably, anyway, so shall I, so my time is over. So thank you very much again.
Thank you, Dr. Samit. And we'll be very happy if you join in our some sessions, if your time permits, and your link, the same link we'll use on the next, today and tomorrow. So anytime to join here, you are most welcome, and we'll be very honored. And thank you very much once again for your time and for such a nice corresponding with me. Always I send an email and immediately you replied. So this is something what I need to learn, actually. So thank you very much. Thank you, Dr. Samit.
Thank you. Thank you very much. Bye-bye.